what we are asked to find. This is just the idea. I'm not graphing anything right now. Exactly. I'm just giving you the idea behind this. So I have a line whose equation is unknown, but I do have two pieces of information about it. I know that it passes through a point that is -1, -2. And I also know that it's perpendicular to a line given to us, whose equation is given to us, which is this. Obviously, this is not the y-intercept. A y-intercept is 0, comma, a number. So going back to our list of equations, when we refreshed our memory on everything here, obviously I will not think of this. I can think of this, though, in which I have a point, and I need the slope. So I will write that equation, which is y minus y1 equals the slope times x minus x1. I know that this is my x1, y1, so this is -1 and this is -2. But I won't be able to continue before I find the slope. Now I have to think. I already have it in my notes that when two lines are perpendicular, the product of their slopes must equal -1, or forget about that, m1 must equal -1 over m2. Or the other way around. M2 must equal -1 over M1. So I am given the slope, but implicitly, indirectly, in other words. So what do I have to do to determine the slope of the unknown line? Exactly. Perfect. I have to find the slope of the green line. Once I have the slope of the green line, remembering the relationship between the two slopes, then I can find the slope I need. Awesome. So how do I find the slope of the green line? Awesome, yes. So I have 5y equals -2x minus 8. Be very careful here. I don't need to write a long fraction line and 5 in the denominator. Just divide term by term. So what I did now, I kept 5y on one side and I moved 2x to the other. When I move a term from one side to the other, I only change its sign. That's all it happens. And I moved 8 to the other side. I have to divide everything, each and every term, by 5. So y equals -2/5 x minus 8/5. So therefore, I have the slope of the green line. Let's call it M2. So what is the slope of the green line then? That's it. Therefore, I have the slope of the orange line. What is the slope M1 of the orange line? That's it. Any questions? The product is equal -1. And it does. So all I have to do next is just plug this in 5/2 as the slope. Paul? Is that okay? Everyone? Stop me if you have questions. Dima, are you okay? Yes, please.
So for M2, the slope is -2 and 5.
Yes, the coefficient of x.
The reciprocal will be, what are you -5/2?
So it has to be the negative reciprocal. You're right. It would have been 5/2, but it has to be the negative reciprocal.
Yeah, but that's how I thought about it too. Or learned it is the negative reciprocal versus the product.
Yeah.
I mean,
same thing. The product has to be equal -1. Or 1 is the negative reciprocal of the other.
See that I just need to do a negative reciprocal there.
That's fine. That's perfect. Good. So all I have to do is just plug it in. Y minus -2 is y plus 2. I have 5/2. X minus -1 is x plus 1. I don't know why, as I said, this we have to be careful. This room, put it on because it's probably blowing on your head, right? You can come closer here. I don't want you to get sick if you want. If you want, it's up to you. Okay. So, or put your hood on. I don't want anyone to get sick. So I think there is no vent here. So I think you're better off here.
So can you?
If you feel like moving around because of the air, please do so. Yes, Paul?
Yeah, I was gonna say, can you go over we get the y plus u. Oh, I see. This minus.
I have to finish it up by putting the slope in there. So I distribute now 5 halves x plus 5 halves, and I subtract 2. This has to go to the other side. And I have to perform these operations. So the y equals 5 halves x. The least common denominator is 2. So this is 2 here. So 5 minus 4. Perfect. So the equation is 5x plus 1 half. So can anyone tell us what, you feel better there? Let me know.
Yeah.
Okay, so can anyone tell us what this is? This is the equation of the line passing through negative 1 comma negative 2 and
Perpendicular to the
good. Any questions? Any questions? Okay, chapter 2.
Question about what
Yes.
happened to 1.9. Can you drop that already?
1.9 is about calculators. If you want to choose something from there, I'll show any of this.
Okay.
It's what I kind of showed, how to find the viewing window of a function, but I will be more than happy to. 5 over 2, this has to be changed into 4 over 2, otherwise I cannot add or subtract fractions if they don't have the same denominator. So 5 over 2 minus 4 over 2 is 1 over 2. Better? Very good. So Paul, will you bring me a question next time and say I want to see this one, or if you have it right now, I can do it right now.
I can bring one next time.
Okay, awesome.
Thank you.
Very good. Good. Chapter 2 deals with functions. Do we know what a function is? Do we know what a function is? Right. If I have the graph. Awesome. Yes. This is a function. I get an input. If I say time is 0, you have to give me an output. If I say time is 5, you have to give me an output. So when we feed a mechanism with an input and we get out an output, that's a function. Let's look at a few situations. And yes, we're going to look at graphs and so on and so forth. So let's look at this. This is the first scenario. Here's the second scenario. No, they don't have to be smaller or bigger. That doesn't matter. And this is the third scenario. In the first scenario, I have 2 bubbles. And the second one too, and the third one too. Okay, let's say I have one 5 and negative 3. And let's say I have here 0, 5, and 3. And I'm just making numbers up, right? And I'm going to say 1 corresponds to 3. I'm going to say 5 corresponds to 0, and negative 3 corresponds to 5. Does this represent a function?
Yes.
Yes, because for each x value, of course, the first bubble has the x values, the input, and the second bubble will always have the y values. As long as I show that for each value of x, there is only one corresponding y value, I'm fine. So you come up with any numbers you want, but I want to show this one now. And these are numbers, whatever number you want. So the first one was a function. Function notation is something like f of x, p of t, v of t, you name it, right? As long as I specifically show the name of the function and the independent variable, that is a function notation. Okay, about the second scenario, is this a function?
Yeah.
Yes, it is. Because for each x value,
We have one.
there is only one y value. Awesome. Function. And here's the third scenario. Is the third scenario a function? No. This exists. It's possible, but it's not a function. It's called relation. This is still the x values, and this is still the y values. The bubble content or the set of x values or y values. Now, what is the name of this, where all the x values can be found? It has a specific name. I used it today. Thank you very much. What is this? Absolutely the range. And this is valid for all of them. This is the domain of this function, the range of this function, the domain of the relation, the range of the relation. Now, there is a very important difference between scenario 1 and scenario 2. They are both functions. But one of the two has a property that the other one does not. And let's identify the property, because I need it in this chapter anyway. Not exactly this moment, but I want to refresh your memory later. Okay, so assume that now I want to create a function here and a function here this way. So, can I create a function here going backwards?
Yes.
Yes. Can I create a function here going backwards?
No.
No. This one is 1 to 1. Not only 1x to 1y, which is the definition of the function, but also 1y. Each y to only 1x. That property is called 1 to 1. 1 to 1. Here, not 1 to 1. In other words, for this function, I will be able to create a function called, what do you think? Come up with a number, with a name, I'm sorry. Inverse. Here, I will create an inverse, but it will not be a function. So, one-to-one functions have inverse functions. Not one-to-one functions have inverses, but not functions. Relations. Okay. We talked last time about the difference quotient. This is part of section 2.1. Are we okay with the difference quotient? Do we want to look at another couple of examples with the difference quotient? Okay, very good. So, remind me which function we looked at. Was it a rational? Was it, I can't remember right now if it was a rational or a, I think it was a rational, but yes, actually I do remember. It was a rational. So give me a quadratic function or a radical square root function. Give me a radical or square root function or quadratic, or both.
Quadratic.
Okay, ready? Negative 2x squared plus 5x minus 10. And let's also work on a square root. Let's say the square root of 2x minus 3. Not at the same time, of course. We can't do that. So let's determine the difference quotient. Difference quotient for each function. The definition of the difference quotient, anyone remembers it? In this class, you don't have to memorize it. In the next one, you have no choice.
F plus h minus fx over h.
Perfect. So I have this, but I don't have the f of x plus h. So let's calculate f of x plus h and then put all three pieces together. So can anyone dictate f of x plus h? And remember, that's another little note for the notebook. F of whatever for this function is -2 times whatever squared plus 5 times whatever minus 10. But now the whatever is, that's it. So how do I write this? Awesome. Awesome. Perfect. Excellent. That's a very good starting point because that tells me that you understand how to look at the function, in other words, or you are able to identify the pattern in the function. And that's crucial. Good. So now I have to simplify this as much as I can before I put it in. Ready? How do I continue? So -2x, hold on, I'll read just 1 second, -2x.
Square.
So please make sure you don't make this mistake. You cannot distribute before you square, because by the order of operations, we have to square first and then multiply. Good. So I have to copy -2 and then
X squared plus 2xh.
awesome. Good. That makes me happy. Because this is the agreement we signed, right? We have an agreement on this. It pops up almost every half an hour. I mean, what can I say? So this is negative, of course, -2x squared and minus 4xh minus 2h squared plus 5x plus 5h minus 10. So now I can continue and write the whole thing. So this is this whole thing. And then minus the function. So -2x squared minus 4xh minus 2h squared plus 5x plus 5h minus 10. So now minus the function. Can anyone dictate the minus the function?
Minus
Careful.
2x squared minus 5x.
Careful. Minus the function.
Minus parentheses.
Yes, or we distribute. We want to put minus in parentheses, or we distribute all the way.
Can we just write it like minus and then like
Of course.
smaller parentheses?
Yes, you can. Yes. So plus 2x squared minus 5x and plus 10. Please write it the way you like it. I'm fine. The reason why I didn't write it again is because it will take me another 3 minutes to write the whole thing. But please write the way you can keep up, the way you you feel the most comfortable with the problem. Okay, what did we say about the difference quotient? This is again for the notebook. We said 2 things about the difference quotient for any function.
Can't be 0. Wait, well, it can't be 0.
The square should cancel.
The h should be the only thing left.
Yes. No. What? So all terms in the top, all terms that do not have h, and maybe some of the terms with h, must go away. That's the first thing. Second thing for sure for any function difference quotient. What is the second thing that must happen? Otherwise, I made a mistake somewhere.
The h
In the denominator,
should go away.
must go away. The final simplified form may still have h in it, but the h in the denominator that I see right now in the denominator, that must cancel out with something from the top. So one more time, 2 things about the difference quotient. All terms at the top that do not have h, and maybe some of the terms with h must cancel out. After that, the second step is, it is mandatory that h in the denominator will go away. It's mandatory that that goes away. Okay, so I see the 2x squared with a negative 2x squared. I see the negative 5x with a positive 5x and a negative 10 with positive 10. All terms without h are gone. Now I'm left with 1, 2, 3. All of them have h in common. Pull it out, please. You cannot simplify before you pull out h. How many terms will you be left with in parentheses? Exactly 3. I started with 3. I have to have 3. What do I have left? Awesome.
2.
Minus h. No. Minus 2. H.
Awesome.
Plus 5.
Plus 5. Only now I'm allowed to do this, not before. I simplify h from the top with h from the bottom, and please write the 1. And the simplified form of this difference quotient is negative 4x minus 2h plus 5. And that's it. Let's also look at the square root function. So I have the difference quotient, the same thing, f of x plus h minus f of x divided by h. And this function now is g, the square root of 2x minus 3. Say it again. Awesome. Of course, I should have used g here because we're talking about g, but it doesn't matter. You understand, it's the same thing. Very good. So let's find g of x plus h. Can anyone dictate? Okay. And then minus 3. Very good. So now the difference quotient. Can anyone dictate the difference quotient for us?
Square root of 2x plus 2h minus 3
Good.
minus
Yes.
square root of 2x minus 3.
Good. So what did we just say about the difference quotient?
All terms without h.
At the top must go away.
Yep.
And eventually, h in the denominator must go away. Okay, what do I do now? I don't see any terms. I can't combine anything. So this is a totally different situation. The idea is the same. I still have to see those terms going away, and I still have to have h disappearing from the denominator, this one. So what do you think we'll have to do now? We did something similar, not with a difference quotient, last time. It's called, the procedure is called,
Rationalize.
but this time, yeah, it's my only chance. This time we have to rationalize the numerator in order to simplify. What do I rationalize it by? And it's in our agreement from day one. And no, I can't square. Yes, the conjugate of the numerator. Awesome. Can anyone dictate the conjugate of the numerator?
Square root 2x plus 2h minus 3 plus
Awesome.
2
And they must be the same because we are multiplying by 1. Top and bottom, I am allowed to multiply by 1. It's not going to change anything. But now, we're going to use the agreement, and you're going to tell me the numerator. I'm only going to, yes, Paul?
Is that the purple or when you're multiplying by that? Using that as base factor.
Yep. We are using our agreement from day one. And we are multiplying this by this. what would you tell me to write? We need to multiply this by this. We are using the agreement we have from day one. 2x plus 2h minus 3. That's okay.
Or no, plus 2x minus 2. It's going to be 2x plus minus 3.
A minus b times a plus b is a squared minus b squared. So it's a difference of squares. Be careful. Now I had to put in there minus and put parentheses to make sure that everyone sees this. So of course I will continue 2x plus 2h minus 3 minus 2x plus 3. And yes, this is what I expect next. What? What do I expect to happen next? I expect that all terms without h have to go away. They do. Otherwise, I'll be in trouble. And then 2h at the top, do not simplify just yet. Please write it one more time. And now what do I do? As I always did for any difference quotient, what? What do I do now? I accomplished the first task. What is the second task? Simplify by h. H divided by h is 1. H divided by h is 1. So the simplified form is 2 over the square of 2x plus 2h minus 3 plus the square of 2x minus 3. And that's the simplified form. Any questions for me? Any questions, Paul? Any questions?
Is there a way to write difference quotient as just dq? Like, do we need to put difference quotient of g of x?
No, no. But you have to write the formula to start with, just to make sure you're not,
Yes.
replacing by something else. Yeah. And in this class, the formula will be given to you. But it's wise to remember it because it's so important. Okay. I'd like to talk about domain because we cannot really talk enough about domain. So I'm on page 150. And let's say we want to look at 58. Remember to do all the problems from these sections, right? That are recommended, and come back and say, I want help on this, I need help on this or that. So we are given a function g of x, which is the square root of x divided by 2x squared plus x minus 1. We're asked to find the domain of this function. What do you think about this? What is the thinking process here? First of all, I see a square root. And I know that the square root is a function that looks like this. So it's not, I would say, the way I like to call it, it's not mathematically correct, but I call them not friendly. The square root is not a friendly function. I have to think. I have to think because Simply, the domain must be greater than or equal to 0. We know that. We discussed that last time, right? So this quantity has to be greater than or equal to 0. If it happens that the square root of it is in the denominator, it cannot be 0, right? So that's the first condition for this. Also, this is a ratio. Ratios are not friendly. Why? Because we can encounter a different problem here. Here, the problem was having a negative number under the square root, which will block the whole thing. Here, in a ratio, there is another potential problem. What is that potential problem? Denominator cannot be 0. So there are two conditions here, two restrictions for x. I have to, from here, to write x greater than or equal to 0. And from here, I have to write that 2x squared plus x minus 1 is not 0. Solving these two conditions will give us eventually the domain of this function. So I have to solve the quadratic equation 2x squared plus x minus 1. Again, if it takes longer than 30 seconds to factor this, it could be factorable or not, it is. But if it takes you more than 30 seconds to factor it, use the quadratic formula. There is no reason to, nobody says that you have to use a particular method, right? So you want to factor, you want to use the quadratic formula. Okay, so can anyone tell us the factored form of this?
You'll have 2x. X on the other.
Because this is plus, obviously I have to have a plus here and a minus here. And it has to be 1 because there is no other way. Let's check. 2x squared, 2x minus x, and minus 1. So then two x values have to be excluded. What are those values that have to be excluded? Negative 1. And this one, you move 1 to the other side and you divide by 2.
1/2.
1/2. And obviously, this is 0 to infinity. These two conditions have to be fulfilled at the same time. So here's what I recommend. I will graph this on the real line. This is from 0 to infinity. And now I have to exclude 1. No units are necessary here. I'm just illustrating. There is no need. And I have to exclude 1/2. So now this is very clear. I think it's clear and tells me what. What will be the domain of this function g? Bracket 0, comma. Awesome. Awesome. Union. Yes. Awesome. Union. That's it. Some situations, some functions require a lot of effort to determine their domain. So be aware of that. I remember we graphed a piecewise defined function, but we just got in the book at this point where on section 2.2 where we have to graph a piecewise defined function. Do you think we should? Do you think that that was enough? Do you remember how to graph a piecewise defined function, or we should do another? Okay, can anyone give us an example of a piecewise defined function? So one more time, what is a piecewise defined function? For particular x values, a function. For other x values, another function. For other x values, not the previous ones, the previous two, of course, another function.
X minus 3.
No, what in a real life situation example, if you can think of one. I have one. I don't know if it's valid anymore because I haven't looked at anything moving forward. It's the previous tax code. I don't know what's happening now. I have no clue. So I can't say about to this year or moving forward. But the previous one was if your income was between, I'm making numbers up right now, between 30,000 and 40,000, a function that will give the tax paid. Between 40,000 and 60,000, another function that gives the tax to be paid, and so on and so forth. That's an example of a piecewise defined function. So again, I don't know how it's done right now. I have not looked at anything. Okay, so let's look on page 160. A more simplified problem or easier problem or a more complicated one? What do you have? What fancies you? A more involving problem or just a simpler one?
Complicated.
Okay, so for that I will take 46 on page 160, and we are given a function f of x with 3 different branches. Negative x is the first one, 9 minus x squared, the middle one, and x minus 3, the last one. First one is less for x less than or equal to 0. Does this remind you of anything? What is that? Of course. It's a piecewise defined function. That's what it is, right? We started with it. That's what it is. It's a piecewise defined function. It's this function for those values of x, is this function for these values of x, and is this function for those values of x. And they cannot overlap because they are defined on different x values. That's one of the reasons we look at this. Not the only one, though. Very good. When I'm asked to graph a function, of course the idea here is to graph. When I'm asked to graph a function, how do I start? What is the first one thing that I have to do forever first? Find the, exactly. That is, once again for your notebook, I refuse to graph, if you want to say something fancy, I refuse to graph or think about the graph before I find the domain of the function. That's absolutely mandatory. First step forever. Okay, so now can anyone replace this with an interval notation for me? Say, oh, I know, this is such and such interval. That's it. I need this symbol, and I'll explain in a minute why. Can anyone tell us the interval notation for the middle part?
No.
Good. I need these symbols. You'll see in a moment, if you remember. And for this, now let's look at these intervals and decide what the domain is. That's crucial. Do you all agree with that? Nothing is missing? There is no gap in the x-axis? In the x values? Yes, indeed. Domain is indeed all real numbers. So I get my chart going. No matter what values I pick, there are 3. There are 2 values that have to be in the chart no matter what. And those values are 0 and 3. Why? Because that's where the change is. That's where change occurs from one function to the other. My next step is under 0, exactly immediately under 0, I will have a bracket facing left and a parenthesis touching facing right. So right under 0, a bracket facing left and touching parentheses facing right. I will do absolutely the same for 3 because there is a bracket facing left and a parenthesis facing right. Touching, of course, because there is no gap. Okay, now I know this part is an overkill, but please bear with me. Tell me which function will you use between negative infinity and 0. I want to write it right there on top of my chart. Perfect. Which function will you use between 0 and 3? I need to write it right on top of my chart. Perfect. And finally, between 3 and infinity, I know it's an overkill, and it's very clear. It must be the last one. There is nothing else. Now I need to identify each piece, what type of function it is, not because I'm lazy and I don't want to work too hard, but because I need to remember that when I graph a linear function, I need 2 points. When I graph a quadratic function, either this way or this way, I may need 3, and so on and so forth. What type of function is this?
Linear.
Linear. I only need 2 points. So please give me a value that you would like between negative infinity and 0. Negative 5. When you plug in negative 5, what do you get? 5. Please plug in 0 and tell me what you get.
0.
Awesome. Done. On the other side, you can say don't. And I'll say, well, if you won't allow me to plug in 0 in the other side, then you will have to plug in 0.000000000000001. You want to do that? No. So please plug in 0. 9. Right here, touching. Right, both these two numbers have to be under 0. Okay, so please plug in 3.
0.
Perfect. Please plug in 3 on this side, and I know you should say no. In that case, I'm going to say plug in 3.00000000000000001. 0. And I need one more because it's a line. 5. 4. Okay. Yeah, I already said 4, and you said 5. So 1. Good. That's all I need. Please dictate the first ordered pair from left to right that you want me to plot. Yes. Next ordered pair you want me to plot. Full point or empty? Correct. You cannot extend this line to the right-hand side. This line is only between, for x values, between negative infinity and 0. Next point that you would like me to plot.
0, 9.
Full point or empty point?
Full and empty point is decided by the brackets.
Exactly. Obviously, this must be a full point. Obviously, this must be an open point. Perfect. And then 1, 2, 3. Full point or open? Full. Now I have to think how to graph this quadratic function. Does it open upward? I know it's silly. When the 1 point is here and 1 point is here, how can it open upward, right? It opens downward because it has a maximum because the leading coefficient is negative. So the middle portion is this. Now it happens that this point is the same, so I have to start here. And 4, 1. It is open, but since it's the same point, it's still there. I am going to ask you about the range of this function, please. Awesome. From the smallest y value to the largest y value. Very good. Any questions for me? Any questions? I have one more concept to discuss, and then I'll give you the work for today. So you'll have like 20 minutes at least. Okay? So this is in section 2.3. We're going to talk about local max, local min, and increasing, decreasing. Decreasing or constant trends. Okay, I'm going to graph a function. Here it is. Just this for now. I'm going to say that this is at x equals 5. This is at x equals 7. What do you think this is from what I listed up here? Of course, local max. Why is it called local? It's called local because I can show you an open interval around it. So this function looks like this, right? At that point. So there is an open interval in which all function values are smaller than that one. But if I cannot show you the open interval, that is not a local max. So for example, if I have this, this is not a local max because the function is not defined on this side. But for this function, this becomes a global max. If that's it, if that's the entire function, that point is a global max. This is a local because I can show the open interval around it where all function values are smaller than that one. What do you think this is? Yes. In some books, the word local is replaced by relative. It's the same thing. If you say a local min or max, or say a relative min or max, is the same thing. Now follow my marker for a second. Would you agree that the trend here is increasing for this function? Would you agree that here the trend is decreasing?
Yeah.
And then it's increasing? We're not interested from what value of y till what value of y. We are only interested in the trend. Between the year 2000 and the year 2010, our salary increased. Not from which value till which value. The trend is between 2000 and 2010, our salary increased. Then between 2010 and 2017, it was constant. Not from which value, whatever it was, but the trend. So I will say here, f increasing on negative infinity to 5, always parentheses, union 7 to infinity. I'm not specifying from which value to which value. I'm just saying the trend is that it's increasing between, for x values, between negative infinity and 5 and 7 to infinity. And the function is obviously decreasing on the interval. That's it. Thank you. We do not put the equal symbol there. Say it again.
What did you write there? Oh, 5 to 7.
Yep. just a quick problem for this, and we can stop. Population growth and decline. The graph shows the population being a small industrial. I don't know if this will work. You can see it better. Okay. So the graph shows the population being a small industrial city from 1950 to 2000. The variable x represents the number of years since 1950. Determine the intervals on which the function p is increasing and on which is decreasing. So it's increasing between 1950 and 19, so this is 25, right? 1975, it's increasing. It's decreasing between 1975 and 2000. Not from which value to which value. What was the maximum population? That's a different question. What is the maximum population and in what year was that attained?
50,000 in 1975.
So 50,000 in 1975. That's how we read max, min, local max, local min, and increasing, decreasing intervals from a graph. Any questions for me? Any questions for me? So I'm looking for the classwork. Here it is. The notes open up. The second problem should take very little time. The first one should take 5 minutes. And the last one on the back, the third one, should take 6 minutes.